Context engineering is the newest AI buzzword, but it's super important. In today's video, I'm going to show you how you can use it to create super smart AI agents. Not only that, you can use context engineering in your day-to-day interactions with LLMs so that you get better and more accurate responses. So what is context engineering? And let's demystify it because it's really simple to use and very simple to understand. I don't want you to worry about anything. This is going to be a very quick, short video for beginners. So let's get started. It's the art and science of filling in the context window. What is the context window? It's essentially the input that your AI agent or LLM will take. The idea is that you want to feed the AI agent in the LLM with the right information at each step. So essentially what you do is provide accurate information for the task you want the LLM to solve. And the best part, this can be done dynamically by the AI agent completely autonomously. So first of all, let's start with the memory systems. The memory systems allow the LLMs to store, retrieve, and also manage information across multiple interactions. The first one is short-term memory, which is essentially the conversation history for a specific task. Let's say you open up the short-term memory will be your interactions with this new chat window. There's also long-term memory that is persistent across multiple interactions. Usually this is handled through databases and specifically vector databases that can be natively used from AI agents. There are also various other memory types that are not very well known, like episodic memory, which uses structured records, and semantic memory that does relationship mapping and conceptual knowledge between different chats. There is also RAG and tool calling. So what is RAG? It's retrieval augmented generation. And what is tools? Tools could be Python function, Python programs, C programs, or whatever other tools are available on the internet. Like for example, a tool could be retrieving the result from an API call, for example, from a weather API. So the LLM can call that weather API automatically and gather the weather data for today. So RAG, its job is to provide relevant information from external knowledge. So LLMs are trained up to a specific date with specific data. One big reason for hallucinations is that they're not up to date. RAG can solve it by gathering external knowledge, real-time knowledge from the web or from documents you provide, and this majorly reduces hallucinations. Also, function calling can allow LLMs to interact with external tools, API, code, so they can get the response from a code, and this also reduces hallucinations as it grounds the response through a specific action. So RAG allows you to have up-to-date information, reduce hallucinations, and also domain-specific knowledge. For example, you could pass the documents of your company and the AI agent can actually use them. Whereas if you didn't have RAG, the LLM would probably not know about the internal documents. At least I pray for that, otherwise you would have a leak. So for tools, you can do external computations. For example, a tool could be a calculator that does simple math. You can also use tools to get real-time data access from the web, and you can also execute actions. For example, you may ask an agent to deploy a new web page or a new website, and it could do it automatically given the correct information. There are various ways for retrieval, and I don't really want to go deep into this because this is a beginner's video, but essentially chunking is the idea of breaking down large document into smaller, more manageable pieces. This is super crucial for effective retrieval. So it's essentially how you structure your databases. So when a new input prompt comes, the model will be able to get the relevant documents. So you have fixed size chunking, which is the simplest one. You split your documents up to a specific length chunks. You have semantic chunk, which splits the document based on meaning and natural semantics. You have recursive chunking that preserves the structure of the document and the relationships between the different chunks. And you also have sliding window, which creates chunks that are overlapping. There is also summarization techniques, which are very useful when you have very large amount of information, and they help the model not exceed its context window, meaning the maximum size of input it can handle. So the idea of summarization, as you can understand, is preserving the key stuff, the key insights for each task. There are two ways: extractive summarization and abstractive summarization. Extractive just tries to summarize from the source documents, so this is more accurate and less computationally intensive. However, abstractive one is very important because you can have better summarization, but you may increase your hallucination rate. There are also some other ones like MapReduce and progressive summarization, but I won't go into details for this, as again with chunk-based retrieval, these are mostly for people that are ML experts and try to create infrastructure and workflows for production and high complex tasks. So the mindset behind context engineering is very simple. It's a fundamental shift in how you think and how you use AI. So previously we had one-time interactions. You asked something the LLM and you expected a simple response. You tried to optimize the prompt, meaning write a very detailed, clear prompt so that the LLM would be able to do its best job on understanding and solving the task. However, context engineering is dynamic and it is about evolving systems. The focus shifts into providing the correct information and to extend the model's use case again over its context limits, which is usually hundreds of thousands of tokens up to millions of tokens. And it's for multi-interaction optimization. So meaning when you interact with an agent or an LLM to solve a task that is complex and you have to interact with it multiple times. So for practical examples using an AI automation that is n8n, you could think of having like your AI agent and adding like the chat memory manager node, which maintains a conversation history and context across multiple interactions with its agent. You can also add vector storages that else can access to get external information from documents you supply. You could also have tools that retrieve from external APIs or even the web. And you can also have hybrid long-term memory. So in conclusion, this is the evolution of how we interact and how we design AI systems. It moves beyond just simply prompting the models to creating actual useful systems. The main idea is provide the right information in the right format, in the right time to the AI agent. You can use memory systems, RAG chunking, summarization, and tools to do just that. And tools like n8n can easily allow you to do that. So what I would suggest moving forward is try to create n8n agents with a Windows buffer memory. You can also add tools to the n8n agent, for example, SERP API, which allows you to extract information from the internet. And in general, if you're just a beginner that uses LLM, try to put relevant information to the LLM. If you want up-to-date knowledge, enable web search. It's just a click of a button. So I really hope that this was a useful introduction to context engineering for beginners. Hope you learned something. And if you have any questions, just let me know down below in the comments.